Okay, so our amplitude, what part of this gives us the amplitude? The 5 is our amplitude. So this is an amplitude of 5. Remember, amplitude is from equilibrium to the extreme or to the peak. Peak to peak, of course, would be, well, peak to peak would be double the amplitude, right? It would be 10. Wavelength. How do you find the wavelength here? It'd be the distance between peaks. We can find that from the number multiplying the x or the theta here, depending on how we have it written. 3x equals 360, where x would be our wavelength. So how do we find x here? Divide by 3. X equals 120. So our wavelength is 120 degrees. What's our frequency? The 3. That means there's 3 waves or 3 cycles in 360 degrees in one rotation of the unit circle. Phase shift. Yes, very good. This is a tough one. To get the phase shift, we take this whole thing inside our trig function and we set it equal to 0. So it's 3x plus 90 equals 0. And the result of that gives us the phase shift. So we subtract 90 degrees. So 3x equals a negative 90, and we divide by 3. So x equals negative 30 degrees. So it's a 30-degree phase shift. What does the negative mean? The negative means if this is our standard wave, we start at what would be considered 30 degrees of that wave. Now 30 degrees is right there. Why is 30 degrees right there? Because this is only 120 degrees here for this wave, because the wavelength is 120. So that phase shift can be looked at in 2 ways. If this were our standard wave, a 360-degree wave, what position would this be here? How many degrees? That'd be 90 degrees. But since this is a 120-degree wavelength wave, that's the 30-degree wave point on the wave. So let's graph this. Actually, I did that all wrong. This should be the 90. We have to go up from a positive 5 down to a negative 5. Now we said there was a negative 30-degree phase shift, didn't we? So what that means is our 0 point, the normal 0 point of the wave, is going to be at negative 30 degrees. So it'll be right there. That's where this wave is going to start. One wave cycle we said was 120 degrees. So from that point, where's 120 degrees? Right here, 90. From negative 30 to 90 is 120 degrees. So our wave makes a complete cycle in that distance. So the way I do this, you'll notice I started out with my starting point here, the negative 30 degrees. I found the end of the first wave using that wavelength of 120 degrees. That was at 90. Then I divided that in half, first of all. I know that the middle of that, we're going to have to be back at 0. Then I divided each section of that into half. In other words, I divided it into quarters. I know there's a peak here at this first quarter, and there's a trough here at that third quarter. So once I had those points, those 5 points, the beginning, the peak, the first equilibrium, the trough, and then the end of the wave, I was able to sketch in that wave. And now I can continue with that wave. We have a peak and another, we can see that each feature is at 30 degrees. So there's another peak at another 30, equilibrium in another 30, another trough at another 30, back to equilibrium. And we keep going like that. Any questions? Now, obviously, if we were graphing this, we wouldn't have that part that's before here. This part over here wouldn't be there because the graph starts at 0. But I always kind of sketch backwards and do that just to give myself a place to start. What do you guys think? Yeah. It's just a rounding. Yeah. A lot of those online applets are kind of sloppy with their rounding. Of course, you can see this one gets a little wicked. There's 6 full waves and 720 degrees. Okay, let's have you guys try an example here. Have you talk through it. So for this one, what's my amplitude need to be? 2, so I have to go up to +2, down to -2. I should maybe give these a little bit front row. 90, 1, 2, 3, 180. So I put my 360 out there. What's my wavelength? $180 degrees. Somebody else want to explain to me how I got 180 degrees? The 2x. So 2x equals 360. You divide by 2, x equals 180. That's my wavelength. Where's my phase shift? Well, I take the whole 2x minus 180. I set it equal to 0 and I solve. How do I solve that? What do I do first, Jeremy? 2x minus 180 equals 0. If I'm solving for x, I have to add what? There we go. So 2x equals 180. Then what do we have to do, Jordan? Divide by 2. So x equals 90. Now this is a positive 90 degrees, which means we would start at what would normally be the 90-degree point. So what that means is this is 90 degrees, not 0. So let's start our wave at the 90-degree point. Instead of starting at negative, we're starting at positive. So our wave starts at 90 degrees. This is the beginning of our wave. Where's the end of our wave? We have a wavelength of 180. What would the other end of that be? 90 plus 180 is 270. There's the end of our wave. So let's mark off our features here. What's the halfway point in between those? 180. What's the halfway point here? We'll just mark it, it's in the middle there, right? And then here, 225. So we know this is at 0, our first peak is here, and that's at 2. This is our next equilibrium right there. Our trough is here at -2, and that's our equilibrium. So there's our complete wave. Now we have to work backwards to get to here, to get to 0. Well, this was 45 degrees, right? So I go back, here's 45 degrees. That will be my trough. At 0, I'll be back to equilibrium again, like that. Does that make sense? So I always map out my first complete wave first, and then I get myself right at my 0 point. Let's do another one. Y equals -3 sine of 4x minus 120. Actually, we're going to do 4x plus 120. Okay, so amplitude. Even though it says -3, the amplitude's still 3. But this does mean the wave is going to flip over. So we have to make sure we don't lose track of that this thing is going to be flipped because it's a -3 and not a +3. Wavelength. How do I find it? Yeah, 4x, that's this part, equals 360. I divide by 4. That wavelength equals 90 degrees. So that's my wavelength. Phase shift. How do I find the phase shift? That's the whole piece in here has to equal what? 4x plus 120 equals 0. For the wavelength, it's equals 360. For the phase shift, it's always equals 0. So I solve that. Where do I start, Jordan? Subtract 120. Good. So 4x equals -120. What do I do next, Jeremy? X has been multiplied by 4. What's the opposite of multiplying by 4? Divide by 4. Very good. So I get x equals -30. That's my phase shift. So I start at -30. So I've got to work my way backwards here. -30 is right here. That's going to be the start of my wave right there, -30 degrees. Where's the end of my wave going to be? Well, my wavelength is 90, right? So from -30, what's -30 plus 90? 60. So the end of my wave is going to be here. Where's the center of that? Right here at 15. Now halfway here is going to be about there, right? Like a -7.5. Halfway between here is going to be right here at, what the hell is that, 37.5? Actually, I got that upside down, don't I? Because this is negative, I've got to flip that. So this one has to be down here. This one has to be up here. So there's my first complete wave. So now my next complete wave from 60 plus another 90 is going to be at 150. Right there, there's my midpoint. So my trough is going to be here. Midpoint, peak is going to be there. So there it is. And obviously, like I've said before, This part here before the 0 isn't going to really be there. So I can get rid of that. That's gone, and I'm left with just that wave. What do you guys think? Not as bad as it looks? Better than a sharp stick in the eye? Want to try one yourselves? Yeah, screw this. Give that one a shot. See what you come up with. Remember, you want to find the amplitude, the wavelength, and the phase. You should find those before you start the graph. So our amplitude's obviously the 2. So we've got to go up to +2, down to -2. What's our wavelength come out to be? 120. 3x equals 360. Gives us 120 as our wavelength. Any questions on where the 120 came from? Okay, how about our phase shift? What's our phase shift? Positive or negative? -30. So that means we're going to start at -30 degrees here again. So we start at -30. Where's the end of that cycle going to be? 90. -30 plus 120 is 90. That's the end of that first wave. Where's the center point going to be? 30. So our first peak is going to be here at 0. First trough is going to be 60. So there's my wave. Now I continue that again. Another 120 would be 210. That's right here. There's my equilibrium, peak, trough. Now, of course, again, the part before 0 really isn't there. Now, on a test or a quiz, if you left this piece here there, I would have no problem with that. If we just left it there, but technically we should erase that little piece there. What do you guys think? Good stuff? What's different here? Yeah, it's not sine, it is cosine. Cosine, if I look at my unit circle, at 0 degrees here, what's the value of cosine? 1. At 90 degrees, what's the value of cosine? 0. At 180 degrees, what's the value of cosine? -1. At 270, the cosine is 0. And back to 360, it's the same as 0. It's at +1. So my cosine wave looks like that. I want you to contemplate for a second. Y equals sine of x minus 90. What would my wavelength be? It's just x, right? So x equals 360. Nothing to divide by. So I have a wavelength of 360. How about my phase shift? Yeah, x plus 90 equals 0. X would be a negative 90. So we'd be starting back here at negative 90 degrees, right? So that'd be the beginning of my wave. Negative 90 plus 360 would be 270. That would be the end of my wave. There's the midpoint. There's my first peak. Here's the middle of that. There's my first trough. Huh. Look familiar? Our cosine, y equals cosine x, is exactly the same as y equals sine of x plus 90. Makes sense? So we can do all the same things with cosine as we can with sine. We can shift them. Now, because we're running out of time, I want to look at something. What's different there? It's x minus pi over 2. What is pi over 2? Not 1.57. 90 degrees. So that's really y equals sine of x minus 90. So you're going through this, they're going to throw in those radians as part of the angle for your phase shift. I just convert them to degrees. It's just so much easier for me to work in degrees than it is radians. Does that make sense? Do you guys remember how to convert radians into degrees? You take that pi over 2, you're going to multiply by 360 over 2 pi. The pi's will cancel out. You've got 360 on top. 2 times 2 on bottom is 4. 360 divided by 4 is 90 degrees. Look familiar? Okay. So then, let's do this one. Y equals negative 2 cosine 3x minus 90. What's my amplitude? 2. Got to go up to positive 2, down to negative 2. Of course, what's going to be significant about this one? It's negative, so it's going to be flipped. What is my wavelength? You got it. It's 3x, so 3x equals 360. We divide by 3 to get 120 degrees as our wavelength. Phase shift is 30. 3x minus 90 equals 0. Solve that for x. X equals 30 degrees. So that means we start at 30 degrees, which is right there. This is a cosine, which means we normally start at the first peak, right? But since it's flipped, we're actually starting at the first trough, down there. Where is the end of our wave? We have a wavelength of 120. We're starting at 30. What's 30 plus 120? 150 will be right there. So that's going to be also a trough down here. What's the midpoint? 90, right? So that's going to be a peak. These are going to be my zeros, or equilibriums. There's my first complete wave. Going back here at 0, what's this going to be here at 0 degrees? Well, 30 degrees brings us back to equilibrium, just the quarter cycle. Does that make sense? Then going this way, of course, this is 150, plus another 120, 270 would be the next. So it'd be down here. This is going to be a peak. These are going to be equilibrium. Questions? Tell me what to do here. Yeah, what's pi over 3 convert to? 60 degrees, so 60, yes. Amplitude is 3, good. So I've got to go up to 3 and down to -3. Wavelength. Jordan, what's your wavelength? We use the 2x, right? The variable. 2x equals 360 is our standard wave. So if we solve that for x, what's x equal? Sure. What's 360 divided by 180? Yeah. No problem. Phase shift, EN. Remember, we take everything inside here, so it's 2x plus 60 we're going to use. And for the phase shift, we set it equal to 0. So we solve for x. So what's our first step to solve that for x? Perfect. Yeah, so divided by 2x is -30 is correct. So that means we're starting at -30. So back here is -30. That's where we're starting. This is a cosine wave, which means we start at a peak, right? Our peak's going to be at 3. That's our amplitude. So at -30, that's where we start. The peak's going to be right there. Where's the end of that first wave? -30 plus our wavelength of 180 is 150, which is right here. That's also going to be at a peak. Start on a peak, end on a peak for cosine, right? The middle of that is going to be right here. That's going to be the trough. Then going each way, we find the middle. Right there is going to be an equilibrium. Going this way, the middle between those two, there's going to be an equilibrium. Equilibrium. There's our wave. If we keep it going, next equilibrium is there. Next trough is there. Next equilibrium is here. You could keep going if you wanted to. And again, if you left this piece on the beginning, I wouldn't mark it wrong, but we really should take it off and start like that. What do you think? You guys want to do something by yourselves? Get ready for that quiz tomorrow. It's in that packet. I think I still need to give you this packet, Ian. Page 363 to 364 in that packet, 1 through 23 the odd. We started these yesterday, finishing them up today. I lied, by the way.